Welcome to Hybrid Btech YouTube channel. Antennas and wave propagation AWP important question 3rd year syllabus. Short answer questions. Define effective height. Second, what is meant by radiation resistance? Define radiated potentials. What is monofailure helical antenna? Fifth one, define directivity, radiation intensity, beam efficiency, effective height. Sixth one, what is antenna efficiency and its relation with directivity. Seventh one, define respiratory theorem applicable to antennas. Eighth one, define and explain quarter wave monopole. Ninth one, what do you mean by impedance matching? What is VSWR range for good matching? And long questions వచ్చేసరికి what is beam area? Define and derive beam efficiency of antenna. Second question long low, explain effective area and effective height of linear wire antennas. Third one, derive radiation resistance and radiated power of quarter wave monopole. Fourth one, write field equations from oscillating dipole. Fifth one, derive far field radiation due to current source, J for small dipole. Sixth one, explain significance of near field and far field. Seventh, discuss retreated potentials in antennas. Eighth one, explain oscillating dipole. Ninth one, how does a small electric dipole radiate? Illustrate and explain. 10th one, explain Helmholtz's theorem in detail. And 11th one, derive expressions for E and H fields radiated by half wave dipole. And 12th one, derive relation between directivity and effective aperture. And 31, discuss loop antenna disadvantages and applications. And 14th one, find radiation resistance of Hertzian dipole of length lambda by 40, lambda by 60, lambda by 80. And second unit, define point source in antenna arrays. Second one, what are source of errors? Draw uniform linear array. Fourth one, what is main disadvantage of binomial array? What are advantages of binomial array? And long question, second unit, principles of pattern multiplication array of 4 elements. Derive field strength for uniform linear array. Third one, derive array factor of broadside linear array of n elements. Fourth one, expression for null beam width of uniform linear array. Fifth one, plot radiation pattern for 4 isotropic elements d is equal to lambda by 2 in phase fielding. Sixth one, derive Fourier transform method of synthesis. And seventh one, explain directivity measurements. Eighth one, explain absolute method of gain measurement with setup. Ninth one, discuss field strength of uniform linear array. 10th one, measure directivity procedure. 11th one, derive array factor and pattern of 2 elements array with equal amplitude and phase. 12th one, compare broadside and fire array, drive BWFM. FN. Explain antenna gain measurement using microwave bench setup. And third unit, short answer questions, applications of horn antenna, very important horn antenna. What is monofailure helical antenna? Helical antenna would important. Write Fermat's principle. And fourth one, design consideration of pyramidal horn. And fifth one, spacing between Yagi-Uda antenna. This is Yagi-Uda long answer question. And long questions, third unit, design and operation principles of helical antenna with diagram, operations and applications of Yagi-Uda antenna, Yagi-Uda antenna with 3 elements working mechanism. Fourth one, sketch typical helical antenna in axial mode, list parameters characteristics, and discuss helix modes of helical antenna, principles and operations of helical antenna with diagram, design 3 elements Yagi-Uda antenna for 172 megahertz, compare axial and normal methods of helical antennas, and find flare angles, beam width, directivity of pyramidal horn. 10th one, describe a folded dipole, show input impedance approximately 300 ohms. And fourth unit, short answer question, define Feed method in reflector antennas, types of reflectors, advantage and applications of microstrip antenna. Fourth one, design considerations of pyramidal horn. Fifth one, advantages of case grain feed. Sixth one, difference between flat sheet and corner reflector antennas. Fourth unit, long answer questions. Corner reflector and parabolic reflector with diagrams. Second one, pyramidal horn antenna operation, characteristics, applications. Third one, parabolic reflector antenna with diagram. Parabolic reflector D is equal to 22 m, F is equal to 5 gigahertz, and eta is equal to 0. One problem is there. And next, schematic of parabolic reflector with Cassegrain feed, explain pattern characteristics of reflector antenna. Sixth one, folded dipole, uh, derive characteristics, impedance and radiation resistance. Compare parabolic and corner reflectors. Describe rectangular microstrip patch antenna radiation characteristics. Ninth one, feeding methods of microstrip antenna characteristics. Tenth one, similarities and differences of lens and reflector antennas. Fifth unit, define space and surface wave in ground wave propagation. What is multi-hope propagation? And third one, define skip distance. Fourth one, effect of earth curvature on propagation. Fifth one, differentiate radio horizon and optical horizon. Sixth one, concept of super reflection. And long questions, reflection of radio waves by earth surface in ground wave propagation, and effect of earth's curvature in space wave propagation. Short notes on muff, ray path, ionosphere characteristics, duct propagation. ఇవి ఇందులో ఏదైతే అడుగుతాడో లేదంటే లాంగ్లో అడగచ్చు, షార్ట్లో కూడా అడగచ్చు. And fourth one, refraction and reflection of sky waves by ionosphere. Fifth one, relation between skip distance and muff. Sixth one, derive muff expression. Seventh one, high frequency radio link. Problem is there, 2000 kilometer, height is equal to 200 kilometers, FC 8 megahertz, and find muff అని అడగొచ్చు ప్రాబ్లం అడిగితే. Eighth one, tropospheric propagation. Ninth, duct and multi-hope propagation with diagrams. 10th, ionospheric reflection of radio waves, derive critical frequencies. 11th, expression for refractive index of ionosphere. 12th, M curve and space wave propagation mechanism with diagrams. Thank you very much. Like, share and subscribe.